Hi, Namaste. Good morning, everyone. Today we have this special class regarding the only introduction of the BJT. We'll come to know after this class how the BJT is going to be formed, what are the different types of transistors that are there, who were invented this BJT, and what are the applications, why we moved from the diode to the BJT. All these things we are going to be discussed. Please keep some concentration over this class because based on this only you can be understand how the electronic circuit is going to be back for the different applications. Thank you. um, yeah, basically in last class we were discussed about this diode. The diode, it is like a PN junction, but it is having some limited applications, like it can be used for the clippers, clampers, and a phase rectifier, full wave rectifier. These are the some advantages we can be grabbed by using the diode. But the diode cannot be used like an inverter. Diode cannot be used like a amplifier. If suppose if you need the inversion operation, if you need some amplification of your input signal, the diode cannot be used. The diode is not helpful for that one, so we need to go for the another type of the device, electronic device, that you can be called it as a transistor. Basically transistor is nothing but trans resistor. It can be transfer the current from the input to the output. That is a transistor. Then generally you know that one. Yeah, uh, this is the symbol of the transistor. Okay, we'll go through this one, how the terminals we can be note, and what is the meaning of B and C and E. Everything will come to know just after two slides. Just wait some time. Right. Yeah, actually the diode was invented by the William Shockley in 1951. Before the 1951 there were having the some electronic circuitry, but they were used that different devices to the amplification of your electromagnetic signal or electronic signal, that you can be called as a vacuum tube. But what vacuum tube occupy the more space, requires the more power, and having the some heating problem with the vacuum tubes. All these some disadvantages were there for the vacuum tubes. These all where you require the amplification operation in electronic circuitry, which are replaced with the junction transistor of the invention of the transistor by William Shockley. Yeah, by using this junction transistor, having some listed advantages are they, yeah, having the lower operating voltage requirement, and it's having high efficiency. It is having the small size and ruggedness, and it is very strong. It's not going to be breakable. Okay, we can use it any place at lower temperature and higher temperature, at military application, everywhere you can use this transistor, because it's very small and it does not require any filament power, all these things. Okay, right? And these are the some advantages. Yeah, we have the junction transistors are two types. Yeah, one is a unipolar junction transistor, another one is bipolar junction transistor. Let us go with that. What is the unipolar junction transistor? Here in unipolar junction transistor, current is going to be carried by the movement of majority carriers of the device. Yeah, what do you mean by the majority carriers? Majority carriers in the sense, here any semiconductor devices, it consists of the two types of majority carriers. Maybe electrons may be majority carriers, or holes may be majority carriers. Okay, the current is going to be carried by the movement of majority carriers, means it may be due to the movement of electrons, or maybe due to the movement of holes. Not to take the current conduction by the carrying the moment of um, uh, electrons as well as the holes. It not going to be takes place the moment of electrons as well as the holes at a time. It's only allows the only current carrying by the movement of charge carriers, which are majority charge carriers. Okay, like that you can be says the unipolar junction transistor can be allow the movement of electrons or movement of holes only for having the charge uh, carrier movement to get the some current passing through the devices. In the bipolar junction transistor, it is another type. This one, in bipolar junction transistor, what happens, the current is going to be passed through the device due to the movement of majority carriers as well as the movement of minority carriers. Means majority carriers, sometimes in some devices electrons, or sometimes at the time holes are going to be minority. In some devices you can be say holes are going to be majority and electrons are going to be minority. Irrespective of that, who are the majority, who are the minority, but is going to be having the some current passing through the device due to the movement of charge carriers. It may be majority charge carriers, it may be minority carriers, charge carriers. It's not going to be particularly to have this one majority charge carriers, but that limitation was there in the unipolar junction transistor, not going to be in the bipolar junction transistor. That need to be understand very clearly. Yeah, next point, what are the types of BJTs? NPN type and PNP type. It's very interestingly, the diode is a back-to-back connection of the diode. Transistor is the back-to-back connection of the diodes. Okay, let me consider in NPN. N is nothing but N type semiconductor and P type semiconductor and N type semiconductor. We are going to be sandwiching P type material in between N type material, that you can be called as a NPN transistor. Okay, in another type of transistor is PNP. Here N semiconductor is going to be sandwiching in between the p-type material, that you can be called as a PNP transistor. Yeah, this is generally, you know that one, how the PNP and NPN. Let me consider, this is P and N. This forms one diode, and this P and this N. This is forms one diode. Once you observe that one, PN means PN PN, which are two devices, which are two different diodes. Let me consider, are going to be connected each other back to back. That you can be called it as a back-to-back connection of the diodes are going to be forming the NPN transistor. Even PNP transistor, just you can be call it as, like, you know that one, PN, it is one diode, and PN, it is also one diode. It is connected back to back, right? This is, you can be call it as a PNP transistor and NPN transistor. Just you have to understand, here we have the three terminals for the BJT. One is the emitter, another one is a base, another one is collector. Okay, here in the sense, emitter emits the electrons, base is going to be take the some current passing through the base, and collector, it is going to be collect the electrons. Same thing here in PNP also we have the emitter, base and collector. You should be understand, emitter, collector, which are connected to the same type of material, but base is going to be having the terminal with the different material. Like, you know that one, in the NPN transistor, emitter is connected with the N type material, collector is also connected with the N-type material, but base is collecting with the P-type material. When you go with that PNP transistor, emitter is connected to the P-type and collector is connected to the P-type, but base is connected to the N-type. N-type is different. Always you should be remember, emitter, collector, which are having the same type of material, but base is having different types of material. That you have to be remember. Here one more point, here in N type, in N material, here having the majority carriers are the electrons. Okay, and minority carriers are the holes. In P material, majority carriers are the holes and minority carriers are the electrons. This thing you have to be understand. This is two diode transistor analogy, NPN transistor, PNP transistor. And in this, what happened, one more very important point how to be understand. Okay, emitter always having the doping level is very high. Doping level of the emitter is very high, and uh, base doping level is small compared to the emitter doping level, and collector doping level is moderate. This condition is wrong actually. I want to make it to correct like this. Base doping level is much lesser than the emitter doping level, and collector doping level is moderately larger than the base doping level. That is very important point. And area coverage by the collector is very high. It means that material you are keeping for the collector area is going to be very high. That may be NPN, that may be PNP, irrespective of that one. And area of the emitter is very small. It is only 25%. And area of the base is 5%, is very, very small. This is third condition you should be remember. Once again I will repeat. Doping level of the emitter is very high and doping level of the collector is moderate. Doping level of the base is very small and area occupied by the base is very small because it is very thin, and area occupied by the collector is very wider and area occupied by the emitter is moderate, and the width of the base should be very narrow. Then only you can be understand it is going to be implementing the diffusion process. Okay, it is going to be using the diffusion process to make it to conduct. And one more point you should remember according to second one, emitter current always is equal to the sum of the base current and collector current, but collector current is much larger than the base current. Base current is very small, sometimes we can be negligible. Let me consider emitter current is 100 amps. It is equal to the 5 amps plus 95 amps, something like that. 95 amps corresponding to the collector current and base current is only 5 amps. Okay, so we can be negligible. So emitter current is almost equal to the collector current. Next point. One more point you have to be remember. Here, which is going to be having the forming junctions. This junction you can be call it as a emitter to base junction. This junction you can be call it as a collector to base junction. Yeah, it means that it is going to be forming the two junctions between the emitter to base, collector to base. Two junctions are there. Those junctions are making like a diode, PN junction. Yeah. Symbol or notation of the BJT. Generally, this is NPN transistor. Just look into this. It is collector current which is entering into the collector. It is a base current and this is the emitter current. This is IC is a collector current, IB is the base current, IE is the emitter current. Here you are going to be take the polarity. At collector is plus, at emitter is minus. You should be remember. This is just a symbolical representation or notation corresponding to the common emitter configuration of your NPN transistor. We are going to be discuss what is the configuration in next slide. Here the voltage between the collector to the emitter is called collector to emitter voltage, VCE. The voltage between the collector to base is called VCB. If you written like you know that one VBC, it will become a reverse polarity. So you should be must care about this one notation. VBC, VCB mean C is the positive polarity, B is a negative polarity. Something like that you should be understand. A suffix whatever it is coming first, that is actually having the positive polarity. Suffix which is coming next, that is having the negative polarity for measuring the voltages. Like you know that one VBE, here base is positive polarity and emitter is negative polarity. You should remember VCE, here you should be remember collector to emitter voltage. Okay, it is equal to always VCB plus VBE. It's very important. At the same time, when you go with the PNP transistor, here, and one more point in the NPN transistor, this arrow mark. This arrow mark is nothing but indicates the current direction of the emitter. When it is looking outside means current direction of the emitter is coming out from the emitter terminal. And one more point, in the PNP transistor we have the arrow mark of the emitter. The current is going to be entering into the emitter. That is a indication of current direction. This is difference between NPN and PNP. One more point you should be remember. Here you should be understand, collector current is going to be exiting from the collector terminal, but here collector current is entering. And they were using the collector is polarity is positive, but here collector is negative polarity. You are taking the emitter is positive. Have you understood? You can write like that one here. VCE minus means collector is having negative polarity for the PNP na, so that we have written minus VC. You can also write equal to the plus VEC because you are interchanged polarity like that. And basically it is uh, minus VCB. Have you understood? You can also write like the VBC. It is also minus VB. You can also write VGB. Okay, like this. You can also write like that one. VEC is equal to VBC plus VEB. But here VCE is equal to VCB plus VBE. That is the difference between NP and PNP transistor. And yeah, transistor action, how it works basically, the transistor. Yeah, let me consider without biasing. Okay, how the transistor is there. Just look into that one. Biasing mean what? Biasing mean applying the proper voltages to make the diode going to be conduct. We are going to apply this voltages that you can be called it as a biasing. If suppose if you're not biasing the transistor, how the transistor internal structure was there generally, Yeah, let me consider. This is emitter having connected with the N type, and you can also see that one collector is also connected with the N type. Already I mentioned that one. E and C means emitter and collector both are connected with the same material, but base is connected with the different material. In NPN transistor, N and N are emitter, collector. In between that, you are having the P-type material, which is going to be having the forming depletion region at emitter to base junction, also forming that depletion region, okay, between the collector to base junction. Okay, generally the majority carriers of the emitter is the electrons, majority carriers of the base is holes, okay, which are going to be diffuse. Generally what happened, the majority carriers, okay, here majority carriers of the emitter are going to be trying to the diffuse to the base. Okay, one more point you should be understand here. This depletion region is going to be spread more into the lightly doped material. Among emitter, among collector, which is going to be doping is very high, emitter is going to be doping very high. Collector is going to be doping moderately, but base is doping very less. So that depletion region is going to be diffused or is going to be spread, extended to the lower doping material. This is spreading into the base. Here it is also spreading into the base. It is also spreading into the collector. But the spreading area of the depletion region is depends upon the doping level of that material. Here depletion region is less spreaded into the emitter but more spreading into the base. Okay, this depletion region at the collector junction more spread into the base compared to the collector. But the depletion region is going to be spreading more to the collector compared to the emitter, because emitter having more doping level compared to the collector. Among the emitter and base and collector, base is going to be having more depletion region because the base is having the low doping level. That point you should be very importantly remember how all these things are going to be work. Generally, you know that one. uh, let yeah, we have to understand biased transistor means we have to apply this some voltage. Then you can be say that one biased transistor. Generally, you should understand. Let me consider the diode is going to be conduct when you have the positive polarity voltage to the p-type material, negative polarity voltage to the n-type material, then diode is going to become conductor. If suppose if you interchange the polarity of the power supply, diode will become reverse bias. One simple logic you should be understand in the transistor. Generally, emitter to base junction is always a forward biased. It means that the diode which is placing for the emitter to base junction is always forward bias, but collector to base junction of the transistor is always reverse bias. We have to be make that one. How? Means by applying the proper voltages, proper polarity voltages, to make that one emitter to base junction always forward bias and collector to base junction always reverse bias. Just look into this arrow mark. We have to be understand here we have the plus. You should remember this one. Plus is connected to the p material, minus is connected to the n material. Already I stated, you know that one. When you have the plus voltage to the p-type material, minus voltage to the n-type material, then you can have this one diode is going to become forward bias. So here you should be understand the voltage between the base to emitter is VBE. B is positive and E is negative. That VBE voltage you are going to be having positive voltage. VBE voltage is positive. If you take it is like a VEB, it is negative only. But you should be have to keep that one positive with respect to the base, because base having the p-type material and emitter having the n-type material. To make that corresponding diode which is forming the base to emitter junction, you have to be apply the positive voltage to the base and negative voltage to the emitter. Then we can have the movement of electron. Then we can have the movement of electron. The movement of electron is going to be moving from the emitter to base. You should be understand very carefully. Emitter to base. When you have the emitter to base, then you can have the in opposite direction we have the current, that is the emitter current, which is coming out from the emitter. Always the current is going to be flowing in opposite to the direction of the movement of electron, because when the diode corresponding to the base to emitter junction will become forward bias, here majority carriers are going to be diffusing to the base material. Some of the electrons are going to be recombined with the majority carriers of holes, and remaining electrons are going to be moved away from the base and going to be entering into the n-type material again. So this is the operation is going to be takes place in NPN. You should be understand what about the CB junction, collector to base junction. I already stated, you know that collector to base junction is going to become reversed bias when you apply this one. When you apply this one, how? Means you are making the corresponding diode which is functionally working to form the collector to base junction to be reversed bias by applying the appropriate polarity voltage. Like you know that one for the p-type material, when you keep that one negative, and for n-type material when you keep that one positive polarity voltage, then obviously that corresponding junction p-n junction is going to become reversed bias. Have you understood? So though it is having the reverse bias which is going to be having the current through the collector, because due to the diffusion and due to the doping level of the base is very less and the area occupied by the base material is very thin, so that which are going to be coming from the base. It means that here when you have the base to emitter junction is forward bias, here majority carriers of electrons are going to be diffusing to the base material. Some of the electrons are going to be recombined with the holes and is going to be forming the current that is called the base current, and remaining electrons are going to be diffusing to the n-type material. Due to that one, the n-type material is going to be having the current, okay, that you can be called it as a collector current. But you should be understand the recombination is very small because of the doping level of the base material is very less, and area occupied by the base material is very less, so that one recombination is very small, so that one base current is very small, but collector current is very high compared to the base current. When we written that equation, like you know that one, IE is equal IB plus IC, IB was very small because recombination is very small, because of the thin layer, because of the doping level of the base material is very small, so that sometimes we can negligible. Same thing when you're going to be applied to this biasing mechanism for this PNP transistor. Similar. Here you have to be make this emitter base to emitter junction need to be forward bias, but we have to be change the polarity of the power supply, because P is coming out. It means that P is acting like emitter, P is acting like a collector. But in the NPN, N is acting like an emitter and collector. So you have to be keep that positive polarity with the P. Always you should be remember negative polarity with N to make that particular diode need to be conduct. If you're not required to conduct that particular P injection, you have to be interchange the power supply. You have to be apply the positive per the N and negative per the P. Then the diode will become reversed bias. Yeah. Here transistor works in three regions. Here what happened in the transistor works in three regions. Here we have the active region, cutoff region, saturation region. When it is acting like an active region, emitter base junction is forward biased. Who will make that one emitter base junction is forward biased? You are going to be make that one. To make it to conduct of the base to emitter junction need to be forward biased by applying the proper polarity voltage. And for the active region, collector to base junction is a reversed bias. Means how? You have to be make the proper polarity of the voltage to make that particular PN junction need to be work in the reversed bias. Generally very simple concept. For the particular junction, it is forming like a diode. How to be apply the P with the positive polarity, N with the negative polarity, the junction will become forward bias. If you apply the P with the negative polarity voltage, N with the positive polarity voltage, that particular junction is going to become reversed bias. Very simple. It's only based on your biasing or voltage or your biasing supply. If you want to make the diode work into the cutoff region, how to be apply the voltage, the proper polarities to make it to not conduct any junction. That is, all junctions are reversal bias. Like base to emitter junction is reversal bias, base to collector junction is reversal bias. Saturation means both junctions are need to be on. Both junctions are need to be on. Very simple. In this, what happen? Yeah, let me to make it to just wait a moment. This one is a normal scenario. This one is normal scenario of the active region working biasing mechanism. For the cutoff, cutoff how it works, it means you have to make it to reverse both junction, like BE junction and CB junction. You should be understand how you can make it to reverse the BE junction. Just you have to understand. Just you have to be keep power supply with plus here minus here. Very simple. These both junctions are going to be reversed. Already it was reverse. Okay. This is also going to be reverse because positive is applied to the N, negative is applied to the P. Okay, right? Next point. If suppose if you want make it to saturate, okay, if you want to make it to saturate this one, then what happen? Just simply you have to make it to conduct both junctions. What to do? Yeah, very simple criteria, just simple. Here what is this one? You have to be make it to p, you have to make it to minus. It's not making, it means that you have to be keep the power supply something like that, external power supply, positive with the p with respect to the negative with the n for both junction, so that both diodes are going to become conduct, so transistor will work in saturation. Okay. Working of NPN transistor, what happens here in NPN transistor? What happened? Very simple scenario here. We have to be give the power supply appropriately with the polarities to make this one B junction is forward bias and BC junction is reverse bias. Though the BC junction is reverse bias, how it is going to be conduct? How the collector current is going to become existing through the collector terminal? One simple point you should be remember. When you give the external power supply something like that to make it to BEC junction is reverse bias and BE junction is forward bias, okay, emitter is going to be ejecting the majority carriers to the p-type material. What are the majority carriers of the p-type material? Electrons. Let me consider we have the 100 electrons are emitted from the n-type material to the base. What are the majority carriers of the p-type material? Holes. Holes having the positive charge, electrons having the negative charge. Let me consider 100 electrons are there which are coming from the n-type material and emitting to the p-type material. Out of 100 electrons, only 10 electrons, let me consider, which are going to be recombined with the holes of the p-type material. Holes of the p-type material. Due to the recombination, which is going to be having the current through the base material, that you can be called as a base current. One more point you should be remember, when you apply this type of voltage with this polarity, the depletion region between the base and emitter junction will become narrower because it's going to be forward bias. Next part. When you apply this polarity voltage to the base to collector, the depletion region will become wider. Though it is wider, when you have the depletion region is wider, not to be conducted basically. But what happening in the action of transistor? Here, out of 100 electrons which are going to be emitting by the emitter, 10 electrons are going to be recombining with the majority carriers of the p-type material, having the some current through the base terminal. But what about 90 electrons? 90 electrons are going to be diffusing to the collector. Though BC junction was a reversed bias. Why which are diffused? Because the base material is having thin area and it is having the doping level is very low compared to the emitter and collector. Due to this reason, though the BC junction is reversed bias, 90 electrons are going to be diffusing to the collector terminal, which is going to be lead to having the collector current in n-type material of the collector. That is the reason how the NPN transistor is working. You should understand this configuration is like that one active region configuration, or means it is working in the active region. You should understand RE is the current limiting resistor, or C is the current limiting resistor of the collector. Let me consider. Electron flows across the emitter base junction. Very simple. You see, when the emitter to base voltage you are applying like this emitter to base junction or base to emitter junction is going to become forward bias. So IB is going to be existing as going to be flowing like this. sorry, electrons are going to be moving like this, but current is going to be moving like this. You see. Next, yeah, what about the base to collector junction? Yeah, electrons are going to be diffusing to the collector, which is lead to be having collector electrons like this. Have you understood? Collector electrons are going to be moving like this. Base electrons are going to be moving like this. Current is going to be moving like this. Have you understood? It means that recombination of the electrons with the holes in base and diffused electrons in the collector, which are going to be forming base current and collector current respectively. These two electron movements are based on the emission of the your emitter only. A transistor currents, just to look into this one. Yeah, to make this one, this junction need to be forward bias, have to be applied this one. Plus is with P, just to remember this one, and minus with the N. This diode is going to become forward bias. This junction is going to become forward bias. That's what I mean to say. This junction is reversed bias. You see, plus is applying with the N and minus is applying with the P. So this junction is reversed bias. You should be understand. This junction is forward bias. What are the currents are there? You just to understand it, emitter current, IB current, collector. But electron movement is not like this. Electron movement is like this. Electron movement is like this. Electron movement is like this. But current is opposite to the movement of electron. Yeah, same for this PNP transistor also. Okay. Here the symbols corresponding to this. Here emitter current. Here we have the collector current. We have the base current. Okay, but here in the PNP transistor, just to see this one, yeah, you have to be understand here. Plus is applied to the P, because how to be make it to this junction need to be forward biased and this junction is reverse biased. You are going to be applying the voltage something like this. We have the collector current which is coming out, just to observe. IB is going to be coming out, emitter current is going to be entering. That is, you should be understand, this is a emitter current is entering into the emitter terminal here, this one, and emitter current is coming out from the emitter terminal. This you have to be observed. This is a transistor conventional current directions for both type of transistor, for NPN transistor or PNP transistor, irrespective of that one. Emitter current is always is a sum of the base current and collector current, but base current is very small compared to the collector current, so that you can almost equal IE is equal to the IC. Configurations, BJT configurations. It means that, what is the meaning of BJT configurations? It means how many different ways you can be connect your circuitry. That is, you can be call it as a configuration. How many different ways you can be ground the terminals of your transistor. That also you can be call it as a configuration. Sometimes you can ground the base, sometimes you can ground the emitter, sometimes you can ground the collector. If you ground the base, that you can be call it as a common base configuration, because ground itself it is the base for the ground itself it is the base for the emitter and collector, so that you can be say common base configuration. If suppose emitter is grounded, that is a common emitter configuration. It means emitter is going to be common for the collector as well as the base. If you ground the collector, that collector will be common for the emitter as well as the base, that you can be call it as a common collector configuration. Just roughly once you go through this one, what is this common base? The base is connected to the ground, just to see. Okay, next one, common emitter. It means that emitter is connected to the ground. You see, though it is NP and PNP, it is grounded. Just to observe here, emitter is connected to ground. Here in this also, here we have the grounded here. What about this common collector? Collector is connected to the ground. Thing is that it's not going to be grounded really, but you are taking the voltage across the emitter terminal. okay, in the common collector configuration. You should be keep more concentration to understand this common collector configuration. We'll see this one. In common base configuration, base is connected to the ground. Base is common for emitter, base is common for the collector. Okay. Whatever the voltage you are going to be applied to the emitter and collector with respect to ground, mean with respect to base. That you can be called as a common base configuration. In common emitter configuration, here emitter is connected to ground. Whatever the biasing voltage you are applying to the base as well as the collector with respect to emitter only. You see this one. Already we had these notations. VCB, here VBE, base to emitter. VCE, output voltage, collector to emitter voltage. IC, collector current. IB, base current. IE, emitter current. This E is the emitter. This B is the base. C is the collector. Here having the place VCC. Here it is a grounded voltage. Here having the place voltage. Here having the negative voltage. To make that one base to emitter junction is forward bias. Okay, to make that one collector to base junction reverse bias, you have to be keep the place here. Just to see collector having the place voltage for the collector. Negative is connected to ground. The negative is connected to ground here. Same like this for the PNP transistor also. In the common collector configuration, how to be importantly remember, the collector is not DC grounded, but it is AC grounded because the VCC source has zero resistance, ideally to an AC signal. Taking this into consideration, we can very well say that collector is a common terminal between input and output of for AC signal purposes only. Then this is your end of the class. We'll go to the discuss more about these configurations in next class. Thank you everyone. If you have any doubt, you can ask me by commenting in channel.